Hello and welcome to Mr. Barton's autograph video number 42. Now this week we're going to move away from biased dice and all that kind of stuff, and we're going to instead focus our attention on coins and how they might be used to introduce the wonders of the geometric distribution. Now I don't know if you've had a similar experience to me, but quite a few of my students really struggle to kind of picture and understand exactly what things like the geometric and binomial distributions are. And as soon as students can't understand something and just rely on trying to remember formulas, then that's when mistakes creep in, especially when it comes to the harder applications questions. And I think autograph has a massive role to play when it comes to really helping students understand what's going on with statistical concepts. So let's have a look how we might use autograph to introduce students to the geometric distribution. Well, I am in advanced mode and I need to crack myself open a new 1D statistics page. And what we're going to do is, like we've done in previous weeks, we're going to generate ourselves a set of data. So I'm going to hover up here to enter raw data, give that a little click, and I'm going to say to the students, okay, new distribution we're going to look at today. I'm going to toss a coin. So I just need to select geometric distribution. I'm going to toss a perfectly fair coin. So the probability of getting a head, if I just go to edit distribution there, is 0.5. And instead of counting how many heads we get, what we're going to count is when the first head appears. So if I get tails first and then a head on the second, that gets recorded down as a 2. If I get tails, 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 and then a head on the fourth, that gets recorded down as a 4, and so on. And I'm going to say to the students, okay, if I was to do this 1,000 times, what's it going to look like? When am I most likely to get a head? Is it on the first toss of the coin or the third toss of the coin? How much more likely is it that I get a head on the second toss of the coin compared to the third, and so on? What's it going to look like? And when we've had a bit of a chat about it, we can create ourselves a sample and we can click OK, and hopefully the students have speculated and hypothesized about what it's actually going to look like. Well, very easily we can get autograph to show us. So if I click on here, dot plot, 1 and 1 looks good to me, click OK, and that's what our distribution looks like. So we've done it 1,000 times and we've got just over 500 heads. Looks like, just over 500 times the head has appeared on the first toss of the coin, about 250 times it's appeared on the second toss of the coin, and so on, and then it drops right down as we get to more and more tosses. And we can ask the students to explain why that might be the case, and so on. But this, I think, is the really, really nice thing about what autograph can do. Because if I just crack myself open a new 1D statistics page, because I'm in advanced mode, I've got this function, which is enter probability distribution. So if I click on that and I again go for geometric and click OK and go for probability of 0.5, this is where the kind of statistics have been worked out for us. So obviously it's a 0.5 chance of getting a head on the first toss of the coin. To get it on the second, you've got to get a tail first, which is 0.5 times 0.5 for the head, so that's why that's 0.25, and so on. But once you've got it set up like this, you can do some of those really nasty probability calculations. So if I hover up here to this function, probability calculations, if I want to know what is the probability of getting a head somewhere between my second and my fourth toss of a coin, well, I click OK, and there it is. It tells me there. It's just down at the bottom, but if I give that a double click, it's 43.75% chance of that. I can also change this around. You may have spotted these cumulative. If I want to know what's the probability I get my head in less than or equal to 3 tosses of a coin, click OK, and again it tells me that that's 87.5%. But that's not even the best of it, because the eagle-eyed among you may have noticed that this little lightning bolt has lit up, and that's always good news when that's around. If I click on this, I can dynamically change the probability of getting a head, so introduce a biased coin, and I can challenge the students to predict what's going to happen to this probability distribution function. If, for example, the probability of getting a head increases, are all the bars going to go up? Are some going to go up and some going to go down? And which ones? And once we've chatted about it, we can see what happens. As the probability goes up, it's so much more likely you're going to get it on your first compared to your second. But this is the thing I think is really interesting. Watch what happens as it goes down. It looks like that first bar and second bar are going to be going to swap positions, but they're not. And I can go right down there to 0.1 and I get that probability distribution function. So that's how you might want to introduce the geometric distribution to your students. Hope that was helpful. See you next week. Bye for now.